Hi, it's Mr. Blystone here, and I'm back with the second video of Unit 1 for Precalculus, and we're talking about multivariable linear systems. So, here are some elimination methods for systems of more than two variables. There's back substitution and Gaussian elimination. Our goal is to get them to row echelon form, where they're in a stair-step pattern with leading coefficients of 1. Then we can actually do this back substitution. So let's go ahead and see exactly how back substitution will work with this system that's already in row echelon form. See, x, y, z, stair-step, leading coefficients 1. So basically what we're going to do is we're going to substitute in. So we know that z is 2, so we'll substitute into that second one, and we'll get y. And then we'll substitute z and y into the first one and get x. So if we do that, we say that z is 2. So in the second one, we can say that y plus 3 times 2 is equal to 5. We know 3 times 2 is equal to 6. Y plus 6 equals 5. So y is equal to negative 1. So let's just write that down. Y equals negative 1. So now we substitute into the second equation. So we can say that y, we substitute rather into the first equation. X minus 2 times negative 1 plus 3 times 2 is equal to 9. So we know that x minus negative 2 plus 6 equals 9. Remember that minus a negative is plus a positive. So we have x plus 2 plus 6 is 9, so x plus 8 equals 9. So x is equal to 1. So we have our answer. We write it in the form of an ordered triple since we have 3 points. 1, comma, negative 1, comma, 2. And there's our answer. Not too bad. So here's an example for you to try on your own. Pause the video, see if you can do it yourself, then play the video again and see if you got it right. Okay, more back substitution. So we're going to plug in z to the second one, and then we're going to plug that answer for y into the first one. So y plus 3 times 3 equals 6. We can say y plus 9 equals 6. Y, therefore, is equal to negative 3. We write that down. Y equals negative 3. So now we plug into the first. X minus a negative 3 plus 5 times 3 equals 22. So minus a negative is plus a positive, so x plus 3, 5 times 3 is 15, plus 15 equals 22. So x plus 18 is equal to 22. So x equals 4. So we have our 3 points. We write them as an ordered triple, 4, comma, negative 3, comma, 3. And that is the answer you should have gotten. Not too bad. Now, let's move on to Gaussian elimination. So that's basically, we're trying to get the system into that row echelon form, and we use what we call elementary row operations. There are 3 of them. We can interchange 2 rows, we can multiply one of the equations by a non-zero constant, and we can add a multiple of one equation to another and replace the answer we get within one of the equations. So let's see an example of Gaussian elimination. Okay, so we have this following system of equations. X minus 2y plus 3z equals 9. Negative x plus 3y equals negative 4. 2x minus 5y plus 5z equals 17. All right, so our first goal, let's try to get rid of this 2x. That, I think, is our first thing. We can do that 2 ways. We could multiply the first by negative 2, and then add it to the third and replace the third, or we could multiply the second by 2, add it to the third, and put that answer as the third. Let's do that one. Let's do the second one. So, what I'm going to do, I'm going to write out exactly what I will do. So, I'm going to take 2 times equation 2. I'm going to add that to equation 3, and I'm going to replace that answer into where equation 3 is now. So let's do that. So let's start off by writing our the equations that are unchanged. So we start with x minus 2y plus 3z equals 9. This equation also won't change. So we have negative x plus 3y equals negative 4. Now, our third one will change, so let's do this so we know. All right, we're going to multiply the second equation by 2, so we get negative 2x plus 6y equals negative 8. And our third equation, we're going to add those two, so we keep that the same, 2x minus 5y plus 5z equals 17. So we're going to add those two. So those cancel. 6 minus 5 is y. 0 and 5 is 5 plus 5z. 17 negative 8 is equal to 9. So our new third equation is y plus 5z equals 9. Okay. So we could work at trying to eliminate that y. But anything we do to do that right now would put an x back in that row. We don't want to do that. So we need to get the second equation, get that x out of there. Well, look at there. If we just add the first and second, that gets rid of our x. So we're going to add them. So we're going to say equation 1 plus equation 2, and we're going to replace equation 2. Okay. So if we do that, our new equations, we have x minus 2y plus 3z equals 9. Now over here, let's just do the addition. So let's write it again. X minus 2y plus 3z equals 9. And we're going to add that to negative x plus 3y equals negative 4. If we add those, x and negative x go away. 3 minus 2 is y. 3z and nothing is 3z, so plus 3z. 9 minus 4 is 5. So our second equation is now y plus 3z equals 5. So our third equation now is y plus 5z equals 9. So we want to get rid of that third y. We can do that. We're going to multiply the second equation by negative 1. So negative equation 2 plus equation 3, and we're going to replace equation 3. All right, so equation 1 doesn't change. X minus 2y plus 3z equals 9. Equation 2 doesn't change. Y plus 3z equals 5. Equation 3 will. How will it change? Well, we're going to multiply the second one by -1, so that's negative y minus 3z equals -5, and we're going to add it to y plus 5z equals 9. If we do that, and we add these, that cancels. 5 minus 3 is 2z, and 9 minus 5 is 4. So we have 2z equals 4. Now, I can already see some of you seeing something, and I can already see some of you, okay, we can do this, we know it's done. We can just back substitute now. We can, but when it comes to later things that we're going to be doing, we want to keep going. So even though we really know we can, because we know, so we just divide by 2, let's do this properly and let's use elementary row operations. So what we do is we multiply equation 3 by 1/2. So 1/2 times equation 3, and we're going to replace equation 3. So we have x minus 2y plus 3z equals 9. We have y plus 3z equals 5. And then 1/2 is z, so not y, z equals 2. Now, I'm not going to take this one any farther, and there's a reason. This is the same system we solved in example 1. So we know the answer. We've seen the answer. It's 1, -1, 2. So, since it's the same as system, we're not going to go any farther. You've seen that. You can look back. The answer is 1, -1, 2, and that's our answer. Not too bad. Okay. So, here's one for you to try on your own. See what you can do. Pause the video. And then start it again. See if you got it right. Okay. So, with this one, again, the first thing we want to do to get this close to row echelon form, let's try to get rid of the 3x here. Now, the best one to do it with is equation 1. We don't want to have to, because we'll have to get rid of it this time. If we use equation 2, we have to multiply equation 2 by something and equation 3 by something. It's not worth it. It's better to just multiply one equation. So let's do this. We're going to say -3 times equation 1. We're going to add that to equation 3. And we're going to replace equation 3. So our first equation stays x plus y plus z equals 6. Our second equation stays to x minus y plus z equals 3. Our third equation changes, so let's look at what we did. So we took -3x minus 3y minus 3z equals -18. And we added that to 3x plus y minus z equals 2. We added those. Those cancel. Negative 3y and y is negative 2y. Negative 3 is z, and negative z is negative 4z. Negative 18 and 2 is negative 16. So our third equation has become negative 2y minus 4z equals negative 16. All right, so now we have our new set of equations. Again, we could try to get rid of that negative 2y next, but if we do that, we're going to end up with an x there again, so we don't want to do that. But we should try to get rid of the 2x that's here. So let's do that. How can we do it? Well, if we multiply again the first one by negative 2, so we do negative 2 times equation 1, we add that to equation 2, so EQ2, and we're going to replace equation 2. So our first one doesn't change again. We get x plus y plus z equals 6. Our second one will. So we're going to multiply the first one by negative 2. So let's just show that we did that. So we have negative 2x minus 2y minus 2z equals negative 12. And we're adding that to 2x minus y plus z equals 3. All right, those cancel. Negative 2y and negative y is negative 3y. Negative 2z and positive z is negative z equals negative 12, and 3 is negative 9. So that's our new second equation. So now we have negative 3y minus z equals negative 9. And our third equation is what it was. So we have negative 2y minus 4z equals negative 16. Okay. So now what we want to do, let's do things one at a time. So we're going to do 2 elementary row operations. So we're going to have to do at least 3 more. So the first one we do, let's make 1 positive and 1 negative, and get them to a common factor to get rid of y. I say we get rid of y by making them 6. 3 and 2, 3 times 2 is 6. So that's a common factor. A common multiple, rather. Common multiple, 6. So we need 1 to be 6 and 1 to be negative 6. If we do that, we can do it this way. So I would make, since this one's going to be bigger here, let's make this one, so we're going to do negative 3 times equation 3. And we're going to replace equation 3. Let's just do this in a piece by piece because I think it's easier. So we have x plus y plus z equals 6. Negative 3y minus z equals negative 9. And we're multiplying this by negative 3, so that gives us 6y. And that is plus 12z equals 16 times 3 is 48. So in this case, negative times negative is positive, so 48. Now we're going to do 2 times equation 2. And we can go ahead and add that to equation 3. So let's do it that way. 2 times equation 2 plus equation 3. And we're going to replace equation 3. So our first one is still x plus y plus z equals 6. Our second equation doesn't change. Negative 3y minus z equals negative 9. Our third one will, so we multiply the second one by 2. So let's just do that. Negative 6y minus 2z equals negative 18. And we add that to 6y plus 12z equals 48. The y's end up canceling. 12 minus 2 is 10. Z equals 48 minus 18 is 30. So now we have 10z equals 30. Now, we can do one of two things next. It doesn't matter which one we do. But I think what we want to do is, what we want to do is multiply the second one by negative 1/3. The reason we want to do that is because if we try and add the first and second together, we're going to get an x back in the second one. And that's not what we want. We have them in close to stair steps. So now we don't want to do any more adding to each other. So our next step would be to say that negative 1/3 times equation 2, and we're going to replace equation 2. So we do that, we have x plus y plus z equals 6. This changes to y plus 1/3 z equals 3. And then we have 10z equals 30. All right, last step before back substitution. We now multiply equation 3 by 1/10. So we say 1/10 of equation 3, and we replace equation 3. So we have x plus y plus z equals 6. Y plus 1/3 z equals 3. And we have z equals 3. So now we can do our back substitution. So z equals 3, we can say that y plus 1/3 times 3 equals 3. 1/3 times 3 is 1, so y plus 1 equals 3. So y equals 2. And then substituting those in for the first one, we get x plus 2 plus 3 equals 6. X plus 5 equals 6. So x equals 1, and our ordered triple is 1, comma 2, comma 3. Took a long time, and some of those steps I probably could have omitted. Admittedly, we could have just divided by 10. We knew how to solve 10z equals 30, and we could have done back substitution. The reason I didn't, like I said, is because when we get into the one of the later lessons, it's going to be a little bit different, and it's easier to do it the way I'm doing it completely. Otherwise, you'll make a mistake. So you really want to get it into the true row echelon form where it's stair-step and coefficients of 1. So I know it took a lot of steps, but that's what you got to do. All right. So now let's go to another example. So this system is inconsistent. What does that mean? Well, let's find out. Let's see. So we go back to our normal Gaussian elimination with elementary row operations. What do we want to do? We want to first get rid of that x right here. What do we do to do it? I would say -1 times equation 1. We're going to add equation 3, and we're going to replace it into equation 3. So we have x minus 3y plus z equals 1. We have 2x minus y minus 2z equals 2. And if we do that, negative x and x cancel. 3y and 2y is 5y. And so negative z and negative 3z is negative 4z. 4z. Negative 1 and negative 1 is negative 2. So that's our second set of equations. So now, let's try and get rid of that 2x. I think that will be our next important thing. How do we do that? I think we multiply equation 1 by negative 2. So negative 2 times equation 1. We're going to add equation 2, and we're going to replace equation 2. So if we do that, equation 1, let's go back so we can see it, is still x minus 3y plus z equals 1. All right. Negative 2 times equation 1 and add it. So the x's cancel. Negative 2 times negative 3 is 6. Positive 6. 6 minus y is 5y. Negative 2 times a positive z is negative 2z. Negative 2z and negative 2z is negative 4z. Equals negative 1 times negative, or 1 times negative 2 is negative 2. Negative 2 and a positive 2 is 0. And our last equation is 5y minus 4z equals negative 2. Something isn't looking right here, but let's keep going. Okay, so now we've gotten the x's out of here. We're left with y and z here, and we're left with y and z here. So let's try to get rid of the y in the third one. So what we do is we say negative equation 2 plus equation 3, and we change it for equation 3. Some of you may see what's going to happen. Just hold on. So our first equation is x minus 3y plus z equals 1. Our second equation stays the same, 5y minus 4z equals 0. Our third equation, so we're multiplying equation 2 by negative 1. Negative 5y and 5y cancel out. That turns to 4z. 4z and negative 4z cancel out. Let's just put a 0 there so we have something on this side. All right, negative 1 times 0 is still 0. 0 plus a negative 2 is negative 2. We have 0 equals negative 2 as our third equation. That is a false statement. This system, therefore, has no solution. No solution. So I guess we figured out what inconsistent means. Inconsistent means no solution. I'm not going to give you a U-try on this one because since we know it's inconsistent, we'll know that the U-try is going to be inconsistent. You can see what an inconsistent system is by yourself in later work. Let's look at some definitions. So, again, from last time, we saw the three possible cases. Let's add some vocabulary. Solution. There's one unique solution, and this is with three equations with the same number of variables as there are equations. We call those consistent independent. Then no solution. No solution. We call those inconsistent. But then there's the case of infinitely many solutions. We call those consistent dependent. So now we see one with infinitely many solutions. So let's go ahead and see what we can't do. All right. So, tell you what, let's go ahead and do something here. So, there was an elementary row operation from the first one that we don't use often, but I think there's a good idea. It's interchanging rows. So, let's do that. Let's exchange equation 2 and equation 3. So all we're doing is exchanging their rows. So if we do that, our first one is still x plus y minus 3z equals negative 1. Our second one now becomes negative x plus 2y equals 1. And our third one is now y minus z equals 0. All right. So now let's do this in the way we normally do it. We have it like this. Now let's get rid of the negative x here. Well, that's pretty simple. All we have to do to get rid of that is add. We don't have to do any multiplying, so let's do that. So we just say equation 1 plus equation 2, and that gives us, and we're going to replace equation 2. So equation 1 is x plus y minus 3z equals negative 1. We add these two, the x's cancel, y and 2y becomes 3y. Negative 3z and nothing becomes negative 3z. And negative 1 and 1 becomes 0. So now we have y minus z is equal to 0. Again, some of you may see where this is headed. But let's just keep going. All right. So the next thing we always do is eliminate the y in the third equation. How do we do that? Well, in this case, let's multiply the third equation by -3 and add it to the second. So we say equation, I'm going to do it equation 2 plus -3 times equation 3, and we're going to replace equation 3. So our first equation, x plus y minus 3z equals -1. Our second equation, 3y minus 3z equals 0. And our third equation, well, let's see here. If we multiply by the third one by -3, and we add, -3 times y is -3y, and 3y cancel out. -3 times -z is 3z. 3z and -3 cancel out. Let's just put something here so we have at least something, 0. -3 times 0 is 0, plus 0 is 0. 0 equals 0 is a true statement. So, since 0 equals 0 is a true statement, we know that this has infinitely many solutions. Now, let's do this. Let's see what we can do here. We can still put something as an ordered triple. Why? In this case, we still have two equations. We can still see that the first two are not the same. So this is not going to be all three the same plane, because equations in three variables create plane. So when we had a 2x2 system, when we said infinitely many solutions, they were the same line. There was nothing more we could do. Here there's a little more. So now what we do, we can still get this too close to row echelon form. What we do is we multiply the second one by 1/3. 1/3 times equation 2. And we'll replace equation 2. So if we do that, we have x plus y minus 3z equals -1. We're going to multiply that by 1/3, so that's y minus z equals 0. And we'll just put 0 equals 0. We don't need to, but let's just put it there so we just know it's there. Now we can do some back substitution. We have y minus z equals 0, so therefore we know that y equals z. So we could do this. We could either plug in. So let's try to find something else. So let's see what we can do. So if we plug in z, so let's plug in z for y in the first equation. So we can say x plus z minus 3z equals -1. So z minus 3z is x minus 2z equals -1. So we can say that x equals 1 minus 2z. Since y and z are the same, if we say that if we call z some number a, so we're going to say z is equal to some number a. Then, since Z equals A and Y equals Z. Y also equals A. So we could replace them. We could say X equals 1 minus 2A. So we have sort of an ordered triple. 1 minus 2A, where A is some number, A, and A. So pick some number, and those are coordinates you'll find. For any real number, we can get a coordinate. So for some number A, we'll have one. So that means basically it's planes intersecting in a line. Okay? So let's look at some geometric representations here. So are the possible interpretations. We can have solutions in one point, like this one. They can all be the same equation, one plane. They can have no solution, and they can be parallel planes, like this. They can have one line as a solution, kind of what we saw earlier. And then this is no solution. Well, we have at any point only two cross. So yellow and blue cross, red and blue cross, red and yellow cross, but there's nowhere the three of them cross together. So there are different ways we can get no solution. So you're probably thinking, well, let's see here. 1, 2, 3, 4 possible ways we can get something other than one point of a solution. It seems that out of different, if we just pick random 3x3 matrices, or 3x3 systems rather, I'm getting ahead of ourselves, 3x3 systems, we're probably going to end up with something that doesn't solve in one point. You'd actually be wrong. With random numbers, you're more likely to find solutions that systems that have a solution than not. That's just an interesting tidbit. It's nothing for precalculus. That's a later course in later math. It's just something interesting. Okay, so problems you should try on section 7.3 are 1 through 20. Do the evens if you're following along. All right, hope you got something out of this. Keep learning.